I want to just spend a minute or two on living organisms, and then we'll come to our break time. I talk about living things because living things are really funny, and I'm going to lighten up a little bit. I've been pretty heavy to you so far, so I'm going to lighten up and let you laugh a little bit about a couple of these things, because I believe God really does have a sense of humor, particularly when he created animals. He did some really, really interesting things. But when we look at animals, what do we see? We see fixity of types. Animals are a certain kind of creature, and they remain that kind of creature. The lack of transitions we talked about. The sudden appearance in the fossil record of all the different kinds of creatures, just sudden abrupt appearance of all kinds of creatures. We see, well, let's see what else. Let's see, extinction we've talked about, more complex plans. Okay, that's pretty much covered that. Let's deal with a couple living organisms. This is one of my favorites. Now, I have to play the role of evolutionist for a minute. If I'm an evolutionist, I have to be able to explain in every living organism where it came from in terms of who its parents were, how it evolved up to that point. And then I've got to be able to explain where it's going, what's it going to become. Well, this is the duck-billed platypus. He's found in Australia. It's a creature that's really interesting because when the British Museum first received the first skin of it from the Australian explorers that were investigating at the time, they said, some Chinese taxidermist is funning us. There's no creature like that. They actually tried to cut the bill off. They found out, in fact, the bill was part of the creature, that this creature really is like that. Well, let's look at what the duck-billed platypus is like and try to figure out, as an evolutionist, where did this creature come from? Well, here he is. It's warm-blooded and suckles its young like a mammal, lays eggs like a birdfish or reptile, has a shoulder girdle and claws like a reptile, a single ventral opening, can detect electrical currents, AC and DC like fish, bill like a duck, hair like a bear, web feet like an otter, flat tail like a beaver, spurs like a rooster, and the male can inject poison venom like a pit viper. Who's its daddy? And where is it going? What's it going to become? I'm really sorry that Gary Larson retired, because I loved his cartoons. Giraffe evolution. Now look at that for a second, and I want to ask you a question. Which is easier, long legs or a long neck? In fact, long legs are a lot easier, because strong bone and strong muscle is not hard to develop. A lot of creatures can do that. A lot of creatures have done that. But a long neck is a complicated problem. It's a complicated problem because in order to survive with a really long neck, you've got to have blood to get to that brain, otherwise you die. So the giraffe has got a very large heart, and that heart has blood pressure that would kill you or I, and that heart pumps that blood all the way up that long neck to keep that brain, and the giraffe does fine. Now that's easy, but if that giraffe didn't show very substantial design in its neck, the moment it bent down to get a drink of water, it would blow its brains out. That doesn't happen because there's special valves in its neck that control that blood flow. And as that giraffe brings that long neck down to get that water, those valves shut down that blood flow, and that giraffe gets down, and his blood pressure in his head hasn't changed a bit. But any creature, other creature that had a long neck like that would probably blow his brains out. Now, a couple more. What's this guy eat? Now, don't anybody say anything yet. I have to tell you something about this. I put this picture up a lot of times when I do biology classes in schools. And there was a big fella in the back of the room one time, one of these guys that kind of walks like this, you know, that obviously played football. And I said, what's he eat? And the kid said, anything he wants. That's not the case, in fact. That creature eats fruit. I want to show you that because I want you to realize that form doesn't dictate function. You can't always tell by looking at something exactly what it does. Let's do the whale. This is whale evolution. I alluded to this before. I'll talk about this now. This is called the whale of a tail. And I'll be honest, when I did this in a biology class at one of the local high schools about 2 months ago, the teacher was really upset by this particular presentation because said I really wasn't nice to make such fun of evolution in this case. But in fact, I'm going to do it anyway. This is a whale's tail. Okay? This is a tail of a whale. A whale of a tail. This is what has to happen for whale evolution. And evolutionists will argue this is in fact the process. What has to happen is you have to have life evolve in the sea. Dead chemicals come alive. Eventually they turn into fish. Those fish decide to come out of the land, out of the sea onto the land. They become cold-blooded reptiles. No small task to go from fins to legs. Then the cold-blooded reptiles have to decide to become warm-blooded mammals. No small task again. Cold-blooded to warm-blooded is a substantial step. Let me ask you a question. How many times a day do you eat? I've had some teens tell me 10, but most of you probably eat about 3 times a day, right? All day, continuously, never stopping. I'm not surprised. But you eat typically, you know how many times a reptile needs to eat? Well, an alligator gets a meal a week, he's probably pretty satisfied. Now, if you could get a poodle a week, that'd be great. But the Gila monster that lives in the southwestern U.S. is an animal that it can actually live on a single meal a year. The point is that a cold-blooded creature can live on a lot less food than a warm-blooded creature. So there's a giant step here from cold-blooded to warm-blooded. Now we have a mammal. The mammal has to decide to go swimming, has to eventually evolve into a dolphin, which will evolve into a whale. Well, let's pursue that a little further. There's 14 changes that I could identify that have to happen for a warm-blooded, land-walking mammal. They actually tell us it's a cow-like creature. And the cow-like creature will have to have 14 substantial changes. For example, the shape of the back of the animal has to turn into a tail. The breathing mechanism has to move from between the eyes and the mouth back to the back of the body, has to have developed the ability to be able to close underwater. If you take a cow and put it underwater, it drowns, but if you take a whale and put it underwater, it swims. No problem. So what has to happen is the cow has to turn into a whale. Well, when I look at that, this is my conclusion. Utter nonsense. That's some of the changes.